everyone, it's Miss B, and I'm going to show you how to derive the side lengths of a 30, 60, 90 special right triangle, which in radians would be a pi over 6, pi over 3, pi over 2 special right triangle. A 30, 60, 90 special right triangle could have 30 degrees as the reference angle, or pi over 6. Or it could have 60 degrees as the reference angle. It's just rotated from one to the other. And 30 degrees would be pi over 6, 60 degrees would be pi over 3 for my reference angle. So I'm going to just look at the pi over 6 reference angle to derive the side lengths. You were told that with the unit circle, the hypotenuse is 1, or the radius is 1. Think of a special right triangle of 30, 60, 90 degrees and visualize an equilateral triangle, because an equilateral triangle is just two 30, 60, 90 special right triangles back to back. It would be my 60 degrees, 60 degrees, and then 60 degrees all together for an equilateral triangle. A 30, 60, 90 special right triangle splits the equilateral triangle in half. That's where we get our 30 degree reference angle, or pi over 6, and still the 60 degrees in the corner here. So if I'm splitting this special right triangle in half with the apothem, the perpendicular line, then I'm splitting the side lengths in half. And because this is an equilateral triangle, all three side lengths have to be equivalent. They have to be 1 for all three side lengths. But I'm splitting the side length in half. So my first side length for a 30, 60, 90 special right triangle, right across from that 30 degree angle, would be 1/2. 1/2 is one side length, 1 is the other side length, and then I'm going to use the Pythagorean theorem to find my last side length. So I'll take 1/2 squared plus x squared, because I don't know that x value yet, equals 1 squared, because 1 was the hypotenuse. Then I'll just use algebra to solve for x. So 1/2 squared is the same as 1/2 times 1/2, which is 1/4, plus x squared equals 1 squared, which is 1. Subtract 1/4 on both sides. X squared equals 3/4. Square root both sides to solve for x. And x equals, when I take the square root of a fraction, I square root the numerator and the denominator separately. So the square root of 3 over the square root of 4, which is 2. Square root of 3, square root of 3 over 2 is my last side length for a 30, 60, 90 special right triangle. Now, if I rotate the triangle, and I have 60 degrees as my reference angle now, the hypotenuse stays as a 1, but the two side lengths rotate. So I have square root of 3 over 2 is now my y value instead of my x value, and 1/2 is now my x value. Same side lengths, just rotated. And that's how you derive the side lengths of a 30, 60, 90 special right triangle.